Okay, so Pythagorean theorem. So again, you should have watched the little Ed puzzle on Friday, and I know that we've talked about the Pythagorean theorem quite a bit this school year already. Can somebody tell us what the Pythagorean theorem says? Go ahead. Okay, so a squared plus b squared equals c squared. And again, this equation was derived from a right triangle. And the reason we call it the Pythagorean theorem is because the mathematician Pythagoras is the one that kind of came up with this. Important to know that A and B always represent the legs of the triangle, and that C is always representative of the hypotenuse. So the hypotenuse is always the longest side of the triangle. And then A and B, as we said, represent the legs and form the right angle within the triangle. Now, one of the things before we look at a few examples here of the Pythagorean theorem that I just want to kind of mention to you is, as we're looking at triangles, it's important that you're able to identify the shortest and the longest sides within a triangle. I don't know how many of you already know how to do that, but I'm going to talk about that right now. If we have this triangle ABC, and I said to you, which side in this triangle is the longest side? How many of you feel confident that you could tell me which side is the longest side in that picture? So Andrew, what would you say the longest side is?
The side that goes from point B to point A.
Yes. So we would say that AB is the longest side. And the reason we know that, obviously in the picture it looks like it's the longest, but the way that we determine that is if we find the biggest angle and we go directly across from that angle, that will always be the longest side. So notice 135 is the biggest angle in the triangle. If I were to say, what's the next biggest side? Well, 25 is the next biggest angle, and the side opposite of 25 is AC. So AC would be the next longest. And then we know that 20 is the smallest angle, so the smallest side would be BC. Pretty easy to identify within a right triangle because the hypotenuse will always be opposite of the right angle. And that's important, when you're checking your values, when you're solving some of these problems. Let's do one more triangle on this just to make sure you understand what I just said. So let's say we have this triangle. Again, we'll make it a right triangle. We'll call it a 30, 60, 90. Sides A, B, and C. If I said to you in this picture, identify the sides from the smallest to the biggest, go ahead right now on your paper and write down the sides in order from smallest to biggest. Okay, so if I were to list these from smallest to biggest, my smallest angle is 30. So hopefully you said that BC is the smallest. 60 is my next biggest angle, so then AB would be the next longest. And since my right angle is here, the hypotenuse would be AC. That would be the longest side in the triangle. So BC, AB, and then AC would be the correct order from smallest to biggest. Okay, now another concept in this lesson that we talk about is this concept of a Pythagorean triple. Now, a Pythagorean triple is just simply a set of integers that satisfy the a squared plus b squared equals c squared. So a set of integers that satisfy a squared plus b squared equals c squared. To give you an example of that, the numbers 3, 4, 5, that would be a Pythagorean triple. You say, well, why is that a Pythagorean triple? Well, 3 squared is 9, 4 squared is 16, and 5 squared is 25. Well, we know that 9 plus 16 equals 25. So that would be considered a Pythagorean triple. Can you think of any other sets of numbers that would make a Pythagorean triple? Another pretty simple one here is a Pythagorean triple. We could take these three numbers and double them. We could do 6, 8, and 10. That also makes a Pythagorean triple because 36 plus 64 equals 100. Okay. Again, this would not be something that I'm asking you to memorize. It's just something that you should be able to check. So if we would give you three numbers and say, is this a Pythagorean triple? Well, if the three numbers are whole numbers, and if you plug it into a squared plus b squared equals c squared and it works, then you know it's a Pythagorean triple. Okay? Now, the main focus of this lesson is you being able to solve for missing parts of a right triangle. So we're going to look at a couple of examples this morning. Probably the biggest thing is knowing how to write your answer. Sometimes it will ask you to round your answer to the nearest tenth. Sometimes it will ask you to give the exact value. And there is a difference there in how we would write that. So I know we've talked about solving these, and we're going to go through one right now. Let's say that we're going to list both answers, rounded to the nearest tenth, and then the exact answer. So I would find my two legs, x and 10. So I'd say x squared plus 10 squared equals my hypotenuse, which is 20 squared. If I simplify that, x squared plus 100 equals 400. If I subtract 100 from each side, x squared equals 300. Now, if I'm going to round this to the nearest tenth, pretty easy here. If I've got my calculator, I'm just going to type this into my calculator. I'm going to take the square root of 300. So if I take the square root of 300 using my calculator, and hopefully we know how to type in a square root. Again, I'm going to put my calculator here just to show you. On my calculator here, it's the second function key, the x squared button, and then 300. If I hit enter, you see that x here would be 17.3 rounded to the nearest tenth. Now, if they would ask me to list this as the exact value, all that means is I'm going to take my radical, which x would be the square root of 300, and I would simplify the square root of 300. Now, this is going back to your algebra class. What I always taught my Algebra 1 students to simplify a radical is take the number under the radical and make a factor tree. We know that 300 is 100 times 3. 100 is 10 times 10. 10 is 5 times 2. So if I then circle my prime numbers, anything that would be a pair gets to come outside the radical. So notice I've got two 5s and I've got two 2s. Well, what is 5 times 2? That's 10. And then anything that does not have a pair stays under the radical. So we would say the answer here is 10 radical 3. And that would be the simplified radical answer. That would be the exact answer as opposed to us rounding it, putting it into our calculator. And I will say most of the time we're just going to list it in this form, so you are going to be able to use your calculator as you're doing that. Any question with that? Okay, why don't you try this one right now on your own? We're going to do, here's the triangle. Oh. We're going to make the top side 4 radical 3. Left side is 4. And you want to find the hypotenuse. So go ahead and take a minute and see if you can solve that for x right now. Okay, let's go ahead and go through this. Hopefully you identified that the legs are 4, so 4 squared and 4 radical 3 squared equals x squared. Now I square 4, I get 16. Important to understand when I square a radical, basically this is 4 squared, which is 16. And if I square the radical, that just takes the radical off. So it's 16 times 3. I then get 16 plus 16 times 3. 16 times 3 is 48. And then if I add 16 plus 48, you get 64. And if I take the square root of that, x is going to be 8. So for our last example, I'm not going to draw the picture on this one. They tell you A is radical 7, B is 3. They want you to find the hypotenuse or find C. Go ahead right now and do the Pythagorean theorem and see if you can identify the hypotenuse. Okay, let's take a look at this. So if I've got the square root of 7 squared plus 3 squared equals C squared. Well, the square root of 7 squared is going to be 7. 3 squared is 9. 7 plus 9 is 16. If I take the square root, hopefully here you got C to be equal to 4.